Hi, it's Elsa from Education. If we were to build a human base in Mars, we will need to cultivate plants there. Today, we are going to learn to build an automated plant watering system here on Earth, hoping one day we can use it in Mars. Let's investigate.
Scientists have been studying Mars for years, as it has certain conditions that make it a favorable location for a human base. If this ever happens, we need to be able to cultivate plants in order to provide us food, like potatoes. In order to grow plants autonomously on Mars, we need to find smart ways to irrigate a plant on Earth without the need for human presence. Let's investigate. From what we already know about Mars, it would be difficult to imagine life as we know it surviving in the Martian environment. The thin atmosphere, the lack of ozone, and the lack of protection from a magnetic field means that the surface of Mars is bombarded with harmful UV radiation and solar winds. However, there are several positive factors. Firstly, a Martian day is very similar to an Earth day, lasting 24 hours and 37 minutes. This means that plant photosynthesis and respiration cycles would remain largely the same. Also, despite being farther from the sun than Earth, Mars still receives sufficient sunlight to allow a plant to photosynthesize. Combined with water that could possibly be extracted from Mars's icy poles, we could have two of the vital components needed to support a plant. If we want to grow plants on Mars, we may have to incorporate our modern-day technologies and tools in order to create sophisticated artificial habitats and irrigation systems. For this activity, you'll need a computer, a jar full of water, Arduino, such as Arduino Uno, Arduino USB cable, soil moisture sensor, servo, a mini 3 to 5 volt is fine, breadboard, a container with sand which simulates our plant, wires including female male and male male, cable ties, plastic bottle, blue tack or adhesive, scissors, a tube, a thin irrigation tube is perfect, a container, and soil. Part 1. Building the water reservoir. Let's start with the actual design of the system. For this step, you will need the water bottle, blue tack, scissors, an irrigation tube, and a bucket. First, we need to create a hole in the cap for our water pipe. This is best done by slowly and carefully carving a hole to the required size with a pair of scissors. Be careful not to cut yourself. Insert the tube into the cap until you're happy with the fit. The tighter the fit, the better. Secure the setup with a bit of blue tack. Cut off the bottom part of the bottle to be able to keep refilling the reservoir. Part 2. Building the irrigation system. Detach the helix from the servo and secure it with cable ties to the tube. Remember to insert the screw in the helix beforehand. The length between the end of the pipe and the helix is important. The bend created by the servo must be sufficiently long to stop the water flow. If the bend is too small, water will continue to flow in the off position. Fix the pipe to the servo. Connect the servo motor to your Arduino like in the graphic shown, and connect the Arduino via a USB cable to your computer. The Arduino IDE includes an example sketch called Sweep, shown on screen. Attach your servo to the helix you've placed in the pipe and test the movement of your pipe. You will need to define the on and off positions. When it looks good, test it with your water reservoir. Change the program until you see the water stop flowing in the off position. Be aware that the height of your water reservoir is key when getting this right. Part 3. Connecting everything together. It's time to test the soil moisture sensor and see how we will incorporate it into our system. The two legs of the moisture sensor work as a variable resistor. The more water in the soil, the better the conductivity, and vice versa. We will use this principle to completely automate our system. Attach the humidity sensor like in the diagram shown, and connect the Arduino via a USB cable to the computer. Write this program. Open the serial monitor to see the output values. In order to find the soil moisture level to decide whether we should water the plant, place the moisture sensor in the humid and dry part of the sand. A value in between both should be your boundary level. Connect the whole system together like in the diagram shown. Now, write a program following this algorithm. Great, now we're ready to leave the setup that will keep our plants healthy on Earth. Water is just one of the many vital resources a plant needs to survive. How could this system be developed to autonomously monitor and keep plants healthy in a Martian environment? Is there anything unique about the environment on Mars that we should take into account? Are there other concerns with the mission to Mars? Remember, everything required for this system has to make the journey with the astronauts, so simple, lightweight solutions are best.